we are embarking on a significant growth phase, like a capital growth phase, where we are going to put in orbit probably 100,000 satellites, or probably over 100,000 satellites, just for communications. And these will be of the version 3 and beyond versus version 2 and version 1 that are currently in orbit. Version 3 is, depending on how you count it, 10 to 20 times more capable than the version 2 satellite. And there were 3 chips that the SpaceX chip design team taped out that are specific to this, that are far beyond state of the art. Which means it's 100 times more bandwidth than the SpaceX Starlink system currently offers, and also half the latency, because the altitude will be about half the altitude. So I think it will actually be the highest bandwidth, lowest latency means of communicating. And the future with AI and robots is actually going to require a lot more bandwidth than we currently use. Because you can imagine, like, what's the bandwidth of a human? It's peak bandwidth of a human is a few hundred bits per second, but bandwidth of a computer can be 1 trillion bits a second. So the appetite for bandwidth of AI and robots is going to be enormous. And then we're also doing the AI data centers in space, which is another massive capital endeavor. But I think it'll be the primary means by which AI can be expanded. It's increasingly difficult to build power plants on the ground. There are very few people who want a power plant in their backyard. So if we wanted to, say, double the electricity usage of the United States, which is on average about 500 gigawatts, we would have to build about twice as many power plants, which I don't think people are, well, most communities are not super excited about that.